Can a group of people walking in steps really break a bridge? Is it just because everyone's footsteps are a little too heavy? In the energy filament theory resonance isn't some mysterious force that suddenly amplifies. Rather, it's a situation where you've perfectly hit the rhythm of how the energy C, or tension field, naturally vibrates within the structure, causing the entire energy path to be raised with each step until it finally reaches a point where the structure can no longer withstand the pressure. Every bridge, every building, and every floor is a section of this energy channel anchored within the energy C, and each has its own natural way of vibrating. It's like a spring or a guitar string, each having its own intrinsic rhythm, the way it vibrates most effortlessly when disturbed. Under normal conditions, without external forces, the structure vibrates in a way that requires the least change to its tension field, just like how a guitar string resonates in its own specific way when plucked. Now, imagine a group of people walking in steps. Their footsteps are perfectly synchronized, which means their timing is aligned with the natural rhythm of the structure, just like a well-rehearsed orchestra playing in harmony. This synchronized effort doesn't cause random vibrations in the structure like disjointed footsteps would. Instead, it steadily adds energy to the most naturally flexible and resonant path. The force is directed efficiently and precisely, accumulating with each synchronized step. Over time, the vibration's amplitude builds up, progressively raising the tension in the structure until it reaches a point where the material can no longer handle the strain, and cracks begin to form at the weakest points. This is where resonance becomes dangerous and different from random noise. It's like swinging on a swing. A small push at the right moment amplifies the swing's motion, making it go higher and higher with less effort. But if you were to apply force at random times or against the swing's natural rhythm, you wouldn't achieve much. Similarly, in resonance, if the force aligns with the structure's natural frequency, it amplifies the motion. However, when the force is applied out of sync with the structure's natural rhythm, it becomes wasted as heat or noise. Think about how bridges behave during resonance. A bridge, like a giant swing, has its own natural frequency. When synchronized forces, such as crowds walking in steps or gusts of wind, continuously pushing the bridge at its resonant frequency, the result is catastrophic. The internal stress patterns of the bridge, along with its tension balance, can no longer withstand the growing force and will fail, leading to fractures or collapse. Similarly, a glass can shatter when exposed to the exact resonant frequency of its structure, even if the sound wave itself is not particularly powerful. When the external vibrations match the frequency of the glass's natural resonance, the energy is absorbed efficiently, amplifying the vibrations within the glass until it can no longer hold together and breaks. This is why certain buildings collapse during earthquakes or certain floors vibrate more during specific frequencies. The energy from the external forces aligns with the building's natural modes of vibration, causing the vibrations to focus on specific parts, where the stress concentrates and leads to failure. This is called stress concentration, and in EFT, it's described as the energy C forcing the structure to vibrate along specific energy paths. In resonance, the external force isn't creating a new, invisible force. Instead, it's directing the existing energy flow along the path of least resistance, the path the structure naturally prefers to vibrate in. The same amount of force, when applied at the correct frequency, produces a much larger effect, seemingly out of proportion with the input. However, if the force is applied against the structure's natural rhythm, it simply gets wasted as heat and noise, achieving nothing of value. So, the next time you hear the warning, "Don't march and step across a bridge," don't dismiss it as superstition. Engineers are not just being cautious, they're reminding you that your synchronized steps are giving the structure a command. Your rhythm determines which energy path the bridge follows, and if the forces align with its natural frequencies, you could be pushing it past the breaking point. This isn't superstition, it's the science of resonance at work, where every footstep you take is part of the bigger picture of how the energy C works within the structure. Tap follow, share it on New Physics, Clear Universe.